Good morning, guys. It's Mr. Middleton here. Today we're going to talk about adding and subtracting radicals. Okay? At the end of the lesson, you should be able to um, add and subtract radicals to be able to simplify expressions. Okay. Um, this lesson, I hope won't be too complicated as long as you pay attention to what's happening. You should be able to, with what you already know about simplifying radicals, um, add and subtract without a whole lot of complication. Okay? There are some things that people stumble over, and we'll point those out and make sure we're okay with working with them. So this is why I don't think this is going to be too bad. We've already done this for a long time. Okay? First or second week, actually first week of this class, if I asked you 5x plus 2x, you would have told me the answer was 7x. Okay? The reason being is you can add these two together. You have 5 of something, you have 2 more of it, you have 7. Okay? 7x. If I asked you z, that was an ugly z. If I asked you z minus 6z, okay, z minus 6z, well, we have 1z here. We take away 6 z's, means we have negative 5 z's. Okay? And you guys know that. So, as we go into the next thing, we're going to talk about radicals. Now, I want you to think of radicals almost like variables. Okay? If our radicals are the same, we can add and subtract them. If they're not, we check to make sure they're not, and then we can't if they are. Okay? So, first problem, we have radical 2 plus 3 radical 2. Okay. So, what number's outside here? It's 1. 1 radical 2 plus 3 radical 2 gives us 4 radical 2's. Okay, notice that the radical 2 doesn't change. We need it to be the same because we won't change it. If I have 1 pin and I add another pin to it, I have 2 pins, not 2 something different than pins. Still a pin. Okay. Alright, looking at number 2. We have 4 radical 6 minus 2 radical 6. Well, put those together. 4 minus 2, that's 2. Radical 6's. Okay, that's basically the unit. Okay. So notice those are just like the problems that we would have if we had x. 3x, 4x. Okay. 4y minus 2y would give us 2y. Just like our variables that were dealing with or have been dealing with all year. Now here's how it's different than variables. A z will never change into an x. A y and a w won't ever be the same. But with radicals, there is a possibility that they can be the same. Okay, so let's look at it. Number 3, initially we have 7 radical 3 minus 12, and we can't simplify this anymore. But because we know about simplifying radicals, if we have a radical that's not simplified, we need to simplify it before we close this problem. Okay, and so I'm going to simplify this. Actually, I have 2 radical 3. Radical 12 is actually 2 radical 3. And so then my problem is 7 radical 3 minus 2 radical 3. Okay, so now at the beginning of the problem they weren't the same. I simplified it and they became the same. And so 7 radical 3 minus 2 radical 3 is 5 radical 3. Now there's no guarantee that it'll always happen that way, that when you simplify it, it will become the same. But we always have to try. Trying for number 4. We have 4 and 5, 2 and 2. Okay, and so this actually becomes 3 times, this is 2 radical 5 plus 2 radical 5. Okay, so 3 times 2 radical 5, that gives us 6 radical 5 plus 2 radical 5, and that together gives us 8 radical 5. Again, we went through all the steps that we needed to go through. At first we couldn't add them together because they were different. simplified this one, found out that they were actually the same, and then added our terms together. Okay, if you want to try these on your own, you can. Make sure you're checking back for your answer. But here we go. Initially, 20 and 12 are not the same. We can't add them, and so I'm going to simplify. Okay, and so I have 4 times 2 radical 5. I have 8 radical 5 here. 12 breaks down to 4 and 2, or 4 and 3, 2 and 2. So 3 times 2 radical 3, so plus 6 radical 3. Alright, now here's an instance where I did everything right. I simplify radical 12, I simplify radical 20, and they didn't come to the same thing. That is okay. If they don't come to the same terms, that's fine. This just means that your final answer is here. Okay, it won't be that every single time we can make it come down to one term. But if we simplify it and we get it down to the simplest radical form and it doesn't add together, we did everything right, it's fine. Okay. Try this one, 18, 60. Okay, not the same numbers initially. Okay, going through, breaking it down. So I have 2 on the outside already. I have a pair of 3s. I have this 2 with no pair, it stays inside. So here I have 6 radical 2. Here I have 12 and 5. 5's prime. I have 4 and 3. 2 and 2. And so I have minus 2 radical 3 and 5 with no pair, 15. Okay, did everything right, simplified everything the right way, still don't have pairs. I mean, they're still not like terms, and so that's our answer, 2 radical 15. So 6 radical 2 minus 2 radical 15. Final answer. Okay? Alright, that's adding and subtracting radicals. If you can do that, you'll be fine. And I'll see you next week.